Hi, welcome to section 2.3, solving equations combining properties. We're going to mix up we're going to, not mix up, we're going to use both the addition property and the multiplication property in solving things. So let's take a look at this guy right over here. We'll solve 3x minus 14 equals the number 1. Well, in order to do this problem, the whole idea is you want to have x by itself. That's how you solve equations. What I usually do, and it's more than what I usually do, what you have to do is use the addition property first before you do any multiplication and division. So what I'm going to do is I see a minus 14. I don't want minus 14. I'm going to add 14 to both sides. 14 plus 14 on both sides. And what happens is the 14s will cancel, leaving you with 15 on the right and a plain 3x. Okay, it's starting to look better. All right, now you take the point of view of the x. That x has got to have no 3 associated with it. X is being multiplied by 3. The opposite is divide by 3. Okay, when I do that, I get a nice plain x, which is our goal. 15 divided by 3 is 5. Very nice. X is 5. I know that's 5. I can plug that in. 3 times 5 is 15. Minus 14 gives me the 1. That's right. I know. So that's done. Let's see. What would you do here? Let me just take a look at the next one. Okay. What would you do here? Okay. I'll tell you what you're going to do here. The first thing, I'm going to do a little bit of writing inside the box. The first thing I would do is, remember, addition property first. 5x plus 2, I don't want that plus 2. I want 0 there. I want 5x. So I'm going to subtract 2 from both sides. Yeah, let's do it over here. Okay, 5x plus 2 equals minus 8. So I'm going to subtract 2 from both sides because that will get rid of the 2 from the left. I'll have a 5x, and then minus 8 minus 2 is minus 10. Okay, now x is being multiplied by 5. Now you divide by 5, and guess what? You're done. X is equal to negative 2. Negative 2, negative 2. And to check it, you plug in negative 2 for x. You'll have 5 times negative 2 is negative 10, plus 2 is negative 8. I think it's nice. That works great. So this is what you do in these problems here. Let's start off with a new sheet of paper. Okay, file, new. Okay. All right, so we have y divided by 4 over 4 minus 4. They like that number 4. 4 is everywhere. Okay, what would you do? If you listen to Professor Silvestri, that minus 4 has got to go. You use the addition property first. So I'm going to add 4 to both sides. I get y divided by 4 equals, that's gone, which was the whole idea. 4 plus 4 is 8. Geez, that looks ugly. I wish I had better tools to do this, but unfortunately I don't. Now, y is being divided by 4. The opposite of dividing by 4 is multiplying by 4. Both sides. The 4's cancel. Y equals this operation. 8 times 4 is 32. I'm putting 32 in there. 32. Nice. Nice, 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 nice. Okay, I'm going to let you do this one. Well, you know what? There's something a little tricky around on this one. I'm going to do this one myself. I keep saying that, but there's always some little gotcha here that I just want to present to you. I want everybody out there to get 100. Multiplication property. Whole goal is to have x by itself. That minus 6 has got to go. Add 6. When you add 6 to both sides, you get 15 on that side. Plus 6, 9 plus 6 is 15. Now the number, you might think, well, what's the number in front of the x? I don't see a number. I see a minus sign. It's minus 1. Okay? X is being multiplied by minus 1. The opposite of multiply by minus 1 is divided by minus 1. Cancels. Nice plain x. 15 divided by minus 1 is negative 15. Negative 15 is your answer for that problem right there. Negative 15. Isn't math fun? Isn't that? I hear a bunch of groans. There's a few people that like it. A lot of people that don't. That's all right. That's what makes it like the world interesting. Can't have everybody like everything. Okay. So we have 5/6t minus 7 equals 3. So have you listened to the theme that Professor Silvestri has given you? Addition property first. Add 7 to both sides. You got to get rid of that term. That minus 7's got to go. When you add 7 to both sides, the 7's will cancel. We'll have 5/6t equals 10. Add 7, 7's cancel. 3 plus 7 is 10. Okay. Now you're multiplying t by a fraction. The trick to doing that is you multiply by the reciprocal. Both sides. Because the whole goal is to have a variable by itself. See? 6's cancel, 5's cancel, leaves you with t. Okay, and I get 12. How did I get 12? T is 12. 5 goes into 10 2 times. 2 times 6 is 12. Or you multiply the tops. 60 divided by 5, you get 12. Either way, 12 is your answer. Next question. Oop, 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 oop. 7. That was 6, right? 6 we did. No, what did I just... Okay, I did number 5. 5. That's what I did. Then I do number 6. I'm sorry about that. Now, this is something relatively new. There's no addition property to start off with this. This is 6y plus y. There's too many y's. You see, every problem that we had so far had only one x, one variable, one y. There's too many y's here on the same side. Well, there's a thing called like terms. Like terms means I can combine these things on one side. Notice I said on one side, not on the opposite side. On the opposite side, you have to do something else. But 6y plus y is on the same side. You've got 6 of these y terms, and one of those y terms, you've got 7 of those y terms. Now, likeness means you have to have the same variable and the same powers, with the same powers. Now, we haven't done much with powers, so that's not going to be a big deal. But right now, just have the same variable. 6 of them plus 1 of them gives you 7 of them. Now we got one variable on a side, and then we can do this problem. 7y divided by 7. Okay, the opposite of multiply by 7 is divided by 7, which is the reason I did that. I get y equals negative 7 over 7 is negative 1. Negative 1. Hit enter. Nice, 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 nice. So what do you think you're going to do here? Well, you know what? I'm going to let you do this one. This is not hard. There's no gotcha. If you understand what I did here, you'll understand what to do there. So I want you to experience success. Okay, so you do that. Now this one here I will do. And to do that one, I'm going to take a nice sheet of paper, new fresh sheet, virtual paper. Write the problem down. You know, it's a lot easier than we're doing the old school paper, pencil. This is using paintbrush and it doesn't look right, and unfortunately that's the only technology I have available to me to do these videos. Okay, all right, what do we got going on here? Well, on the same side we have two variables, two of the same variable. You need to combine them because they're like terms. Now, how do I combine them? Well, the 13 has got nothing to do with what I'm saying, so I'm going to copy that down. I have a negative 1a. If you don't see a number, it's 1. So negative 1a plus 4a. Negative 1, those are like terms, so negative 1 plus 4 is plus 3a. Now we got one variable on that side, which is nice. So in order to do this problem, it looks like everything else we did. We're going to subtract 13, leaving you with 3a. So subtract 13 on both sides. I'm going to have a negative 6 when I subtract 13 from 7. And then when I divide by 3, I get negative 2. I'm going to put a negative 2 in there. Hit enter. And that's all we get. You're going to get sick of getting things right. Now, is this something that you should be able to do? Yes, it's something you should be able to do. I will let you do it based on what I just did here. Okay, based on what I just did here, you're going to combine these like terms and go to town. So I'm going to do that. I'll do this one. Why not? You guys are paying me, so I'll do that. Actually, what you're paying me for is to show you how to do these problems, and hopefully you'll grab some knowledge from that. And but I don't want to do every problem, because that doesn't, you're not learning anything. Okay, so you have to force your mind to do these problems. So what I'm going to do is copy what I can copy down. These are like terms, same variables. You got negative 1z minus another 1z, you get negative 2z's. Now the rest of this, what I'm going to do is I'm going to subtract 6 from both sides, because you got to, from the point of view of the z, I don't want that 6 there. So I'm going to subtract 6 from both sides. That cancels here. Negative 2 minus 6 is negative 8. And then z is being multiplied by negative 2. I need to divide by negative 2. That negative 2 cancels. We have a z equals negative 8 minus divided by minus 2 is 4. Negatives cancel. 8 divided by 2 gives you the 4. Nice. Okay, not that much left. Oh, here this is a little bit different. A little bit different from what we did. See, these two things are not like terms in the sense that you can't combine them. Like terms have to be variables on the same side of the equation. These are on opposite sides. Opposite sides. So how do you handle that? Well, I'm going to show you. I'm going to show you right now. So right now we're going to put down the problem. 2y plus 6 equals a negative y minus 6. Well, right now what I'm going to do is try to bring together the y terms. And so far, every problem we did when we did addition property is you added or subtracted a raw number. Now, there's nothing that says that you can't add or subtract a variable. Okay? So what I'm going to do to bring over this y, or at least get rid of it from the right side, is I'm going to add y to both sides. Whatever you do on one side, you're going to do on the other. Okay, so 2y plus 2y plus y is 3y. Okay, bring down the 6, because that didn't get involved with anything. The y's canceled here, get minus 6. Now from here, I'm going to just say, listen, you can do this. We should be able to do this. You're going to subtract, this looks like every problem we did so far. Negative 6 on both sides. We're going to subtract 6 from both sides. We get 3y equals negative 12 when you do that. And then when you divide by 3, I get y equals negative 4. Negative 4. So basically this problem was a little bit harder in that I had to actually add or subtract, in this case add a variable, add y to both sides to get this thing to behave. Okay, now I'm going to do this one too. Okay, we got 5r minus 3 equals 13r. See, now the problem with this is we have r's on both sides of the equation. And you really should have r on one side. It doesn't matter which side you put the r. It really doesn't, as long as there's r on one side. It's just that I'm used to having my variables on the left. That's the only reason I have my variables on the left. But I'm going to show you that it doesn't matter. Look, I'm going to say 5 minus 5r on this side. Whatever you do on one side, you do on the other. Minus 5r. That cancels. Minus 3 equals 13 minus 5 is 8 of those r's plus 10. Okay, good, nice. Now this r term is got a plus 10 attached to it. I don't want plus 10. Get rid of the plus 10. Subtract 10 from both sides. Doing so, I get negative 13 equals 8r. And then divide by 8, I get something that's a fraction. There's nothing I can do. Negative 13 over 8. It doesn't. You got to get used to the idea that the world is not always onesies and twosies and fives. Okay, not whole numbers. Negative 13 over 8 is a number. I'm going to write that number. Negative 13 over 8. And that's simplified. And I believe I did it right. That I did not do it right. Now, why didn't I do that right? Wow. Oh, wow. Can you see what the problem is? Plus 11, plus 10. Man, I've got to be more careful. I've got to be more careful. So let's see if we can salvage what I did so far. Let's write down the problem correctly. 11, same, subtract 5, 11. Okay, same thing. I'm going to subtract 11 from both sides. I'll have negative 14. Then I'm going to divide by 8. I'm going to have negative 14 over 8. So negative 14 you could simplify because that's negative, divide top and bottom by 2. Negative 7 over 4. So let's see if that's a better answer. I hope it is. I hope it is. Hit enter. That's better. See, if you don't write down the problem right, you're not going to get it right. Math is not forgiving. Okay, so I'm going to let you do this one. I will let you pick. Personally, I'd probably just add x to both sides and keep the x on the right. But you do whatever you think is best. Because whatever you decide to do, whatever you do on one side, you must do on the other. Okay, now this problem here is a little bit, well, I think it's a lot different, actually, now I look at it. We really never had problems with parentheses before, okay? And so what do? Well, the first thing you're going to do is write the problem down. And I could safely say that when you have problems with parentheses, the parentheses have got to go. That's the first thing I would do. You got to get rid of them. And it's not hard to do. What you'll do is you just multiply through those parentheses like so to liberate these terms. So 4z plus 28. At least I got rid of the parentheses. Now what do you do next? Well, I think I'm going to get rid of the z from on the right. Because if I subtracted 4z from both sides, I'll end up having a negative number on the right. Not that that's bad, but negativity brings you down. So what I think I'm going to do is just subtract the z from here. At least you get rid of it from one side. Negative z over there. The z's cancel, leaves me with 3z plus 28 equals 7. I'm going to subtract 28. Now, this looks like a problem we've done many times, so I'm going to subtract 28. Okay, so when I subtract 28, that leaves me with the 3z. The 28s would go away, so 7 minus 28 is negative 21. And that's a nice, I just got to be the answer, because very few times have we got fractions. Negative 21 over 3 is 7. Whole number. I'm going for it. Yes. Bingo. Not right. Why is, negative, see, I'm showing off. See, okay. It's negative 7. Sorry about that. Negative 7. Negative 7. Check your answer. Nice. Okay. So it's a good thing that you have multiple tries on these homeworks. Okay, let me take a look at what the next one is. You know what I'm going to do? I'm going to leave you with this one. I'm going to leave you with this one. Enjoy this one. Because the next one's harder. I will do the harder problems. A harder problem, and I'm going to go very slow. Very slow. You know what? I'm impatient in my old age. I want things done right away. 5, and then I make mistakes. And so do I actually save time doing things right away when you have to do things over again? Nah, you think I'd learn. But maybe you can learn from my mistakes. Now, first thing I would do is say, well, is that the right answer? 3 plus 2c, 3 plus 2c, 5c minus 4. Yes, that's right. Step 1. Parentheses have got to go. Okay, we'll get rid of them. What's the number in front of the parentheses? It's not 4. It's negative 4. Always with the sign in front, and I'm going to multiply through the parentheses. Like so. This 5c I'm just going to write down. It's not involved in that operation. So negative 4 times c, negative 4c. Negative 4 times negative, it's always not 7, it's with the sign, negative 7. So negative 4 times negative 7 is 28. And I'm going to copy the rest down. Do one operation, copy the rest of the stuff that wasn't involved in the operation. Well, these are like terms because they're on the same side. So I could say 5 of those c's minus 4 of those c's are 1 of those c's. Copy the rest down. And I got c's on both sides of the equation. I got to get rid of one of those c terms. And I think the best way would be to subtract c here. Subtract probably the smaller value. I think that's a good way, rule of thumb. Subtract the smaller number of c's. That's 1. So I subtract 1 c, subtract 1, subtract 1. This cancels. Got 28 equals 3 plus c. Okay, 2 minus 1c. I'm going to subtract 3 from both sides. I got a nice plain 25. Hoping and praying that that's the right answer. Nice work. Okay, I should have a little button, virtual applause. I'm going to find such a button. And I will do this one. I will do this one because that one looks like you got a couple of sets of parentheses, so you just got double the work. File, new. Okay, copy the problem. 4 times 2 minus t minus 3 minus 2t equals 2. Okay. Parentheses have got to go. Multiply through here and here. Now, what's multiplying this set of parentheses? If you don't see a number, it's 1. And what I'm multiplying through is with the sign negative 1 each term inside those sets of parentheses. So doing this operation, I have 8 minus 4t minus 3 minus a minus is plus 2t equals 2. Okay. And what do we got left? Okay. This looks like a t, but it's a plus sign. These are like terms right over here. They have the same variable on the same side. And actually, these are like terms too. Okay. Numbers are like terms. So I'll do the 8 minus 3 is 5. I'll do minus 4t plus 2t is minus 2t. Okay, I cleaned up that left side, 2. I'm going to now subtract 5. Subtract 5. Negative 2t equals negative 3. I'm going to divide by negative 2. Negative 3 over negative 2 is equal to, well, the negatives will cancel, 3 over 2. Best you can do, 3 over 2. I hope that's right. I really, really hope that's right. 3 over 2. Hit enter. Fantastic. Super duper great. Fantastic. Next question. Oh, of course we have to have a word problem as our last problem. It's not a very hard one. And it's something that you can relate to because you have to pay tuition and stuff, and there are fees, and you got to pay per every credit. But anyway, here we have a part-time student pays a student fee of $45 plus $180 per credit. Okay, so how many credits is a part-time student carrying who pays $14.85 in total? Okay, so let's come up with a basic representation of a formula that comes up with how much she has to pay. She has to dish out $45, even though she got no credits. Now, for every credit, I gotta pay $180. So that's what we're saying. X is a credit, the number of credits. Every credit you get is $180 plus the $45 fee. And that's going to equal the $14.85 that they speak of here. So what do we got? I'm going for, that's the equation right there. That's the equation right there. Well done. And so what does this person take as credits? Okay, this better be a whole number because I've never seen a school that has a 0.5 credit, so a fraction of a credit. So what I'm going to do is I'm going to subtract 45 from both sides. So when I subtract 45 from this, I get 1440. Divide both sides by 180. Okay, zeros cancel. 144 divided by 8. Looks like it might be 16 credits. That's not right. That's not right. Jeez, I'm losing my mind. Okay, that's your calculator. If you're losing your mind, divided by 8 equals 18 credits. Yeah, that's better. Okay, 18 credits. Busy person. Boy, she's taking a lot of credits. 18 credits. Hit enter. What? 845, 1440, 180. Oh, come on, man. Why am I losing my mind so much? Oh, dear. Here. It's 1440 divided by 180. I lost a 1 in there. Okay, so let's do this again with a calculator. Clear it. 1440 divided by 180 equals 8 credits. Okay, so she's not that busy. Not that busy. So here, 8 credits. Well done. And so what should you get out of this? Well, certainly the combination of addition and multiplication properties, understand like terms, understand that you have to get rid of parentheses, and probably the most important thing that you can carry out of this is that don't rush through anything, because when you rush through things, you think you're saving time, but when you make it, ultimately when you make a mistake, you'll end up wasting more time in solving the problem. Okay, so we'll see you in section. Oh, by the way, there's a quiz that you should do that involves 2-1, 2-2, and 2-3. Okay, so do that quiz. It's quiz 2A. So after you do section 2-1, 2-2, 2-3, you're ready to take 2-3 and go ahead and do that. All right, we'll see you in section 2.4. Bye.